This is a video on honors chemistry about the gas laws that we learned on Wednesday, which is today on the day of recording. So we have these three problems here. As I'm sure that you can all see, we have these three problems, and these three problems are featured on the Gas Law Practice 2 worksheet. So that is where these problems are located, and all of these prompts have to do with gas laws and how to find certain variables that they are related to, which that's kind of not the best explanation, but I'll go further into it. So let's just begin with the first question. This question number 1. If a gas has a volume of 3.27 liters and a pressure of 182 kilopascals, what will the pressure be if the volume is changed to 2.15 liters? So what we have to understand is that this problem utilizes what is called Boyle's law. Now, that is Boyle's law. And Boyle's law is a law of gas that involves an equation which is P1 times V1 is equal to P2 times V2. P stands for pressure and V stands for volume. So we are going to use this equation with this problem. So if a gas has a volume of 3.27 liters and a pressure of 182 kilopascals, what will the pressure be if the volume is changed to 2.15 liters? So we know what we already have. We have 182 kilopascals and 3.27 liters. And that is going to be our pressure 1 and our volume 1. And then the question is asking, what will the pressure be if the volume is changed to 2.15 liters? So we do not know the pressure, but we do know the volume too. We do know the volume. So what you would do in this case is that you would solve this like an algebra equation. And what I mean by that is that you would start, the easiest way for me to do it is to start on this left side, because we already have these two numbers. And the best way to start this is by simplifying them. And 182 times 3.27 is equal to 595. And keep in mind, we have to keep the same number of sig figs. So as we can see, these have 3 sig figs, and this has 3 sig figs. Because originally, when put into a calculator, the answer is this. But we have to keep 3 sig figs, which we can achieve by just putting this number. So then, we get 595 equals P2 times 2.15. And now, we would treat this like an algebra equation once again, because we're going to treat this as a variable, because it is. We don't know what it is. And we have this 2.15 that is multiplying the P2. So what we'd have to do is cancel this out by dividing both sides by 2.15. And when you divide both sides by 2.15, you would get an answer of 277, rounded to 3 sig figs. And so that would equal P2. And keep in mind, though this looks complete, we're not done yet, because this is not what the question is asking. It's asking what will the pressure be if the volume is changed to 2.15 liters. So in order to fully finish this problem, we need to write down the unit of measurement, which in this case is kilopascals, written like this. So the answer would be 277 kilopascals. And that's how you would solve that. Now we can move on to question 2. If a gas has a volume of 4.03 liters at the temperature of 450 Kelvin, what will the volume change to if the container is heated to 900 Kelvin? Now, this question involves Charles' law. Charles' law. And the equation for Charles' law is V1 over T1 is equal to V2 over T2. Now, as you can see, this is different than Boyle's law. In this case, volume, the V still stands for volume, but we have this T, and T stands for temperature. Now, in this equation, you will notice that this K shows up twice, and K is for Kelvin, and that is a unit of temperature. So if we go back to the question of interest, we see if a gas has a volume of 4.03 liters at the temperature of 450 Kelvin, what will the volume change to if the container is heated to 900 Kelvin? So we are going to use this equation format to correspond with this question as we did with the first question. So we already have our knowns. If a gas has a volume of 4.03 liters at the temperature of 450 Kelvin, what will the volume change to if the container is heated to 900 Kelvin? So we don't know the volume. We only know that it's going to be 900 Kelvin on this side. So this is what our equation looks like. Now, this can look a little bit scary to some people, but I'm here to tell you there is a very easy way to do this. And it involves cross multiplication. So, what we want to do in this case is multiply the 450 times the V2 and the 403 times the 900, which will look like this. So 450 times V2, I would just write it as 450 times V2. And then we have 4.03 times 900. And keep in mind, this 900 has only one sig fig from the 9. So our answer must have, well, the number that we get from multiplying these two must have only one sig fig. And that would be 4,000. And now, this equation, you will notice, looks very similar to a place that we got with the first problem. And you'd be right. What we do here would also be the same. We would just divide by 450 on both sides to isolate the variable. And what we would get from all this would be that V2 equals 9. And that is rounded to 1 sig fig because of the 4,000. And keep in mind, this is not done because we have to use a unit of measurement, which we are finding volume in this case. So this would be V2 is equal to 9 liters. And that would be the answer. Now we are on to the final problem. If a gas has a pressure of 328 kilopascals at a temperature of 300 Kelvin, what will the pressure be changed to if the container is cooled to 100 Kelvin? So, what this utilizes is a law named Gay-Lussac's law. Now, Gay-Lussac's law is like Charles' law in that there's a that it involves fractions and division. But instead of it being volume over temperature, it is pressure over temperature. So the equation would be P1 over T1 is equal to P2 over T2. So we are going, so once again, we have this base, so we are just going to implement these numbers into this equation. So if a gas has a pressure of 328 kilopascals at a temperature of 300 Kelvin, what will the pressure be changed to? So we don't know the pressure. The container is cooled to 100 Kelvin. And like Charles' law, the easiest way to do it is to cross multiply. So we would get 300 times P2 equal to 30,000, because that would be rounded to 1 sig fig when multiplying these two. And then we do the same. We just divide by 300 on both sides, and that would give us an answer of P2 equal to 100. And to write down the unit of measurement, that would be then P2 is equal to 100 kilopascals. So that is all the equations and how you would solve each of the gas laws. And also in the notes, there is a thing called a combined gas law. As of the day of recording, we haven't done anything with this yet, but we do know about it. And the combined gas law is as follows. P1 times V1 over T1 is equal to P2 times V2 over T2. P2 times V2 over T2. This is the combined gas law. Now, I'm assuming that you would use this in cases where, well, obviously you need to have one set fully, and you don't know some of the other variables on this side. You might know one or two maybe, but you still need to know one other one. And this is going to be more lengthy than just these, obviously. But in all, that is how you solve each one of these problems, and I hope this video helps, and that's it. Peace.